Hello students, the another graphical representation or transformation that we are looking into is rotation. So here we are taking, you can rotate the matrix around the whole space. So any degrees of rotation can be done from 0 to 360 degrees. Here we are taking a example of a matrix or a vector that is being rotated by 90 degrees anti-clockwise. So before rotation, the vector, normal vector is, that is before transformation, vector is represented by xy. So let us see what will be the transformation values. So this is algorithm. So I have, let me take an x and y coordinate. Let me just take one vector, that is this vector, which is lying on the x axis. So what will be the coordinates? 1 and 0. So this will be your vector. If I am rotating this vector by 90 degrees, so it lies on what? It lies on y-axis, right? So if it lies on y-axis, what will be the coordinates now? The length of the vector will remain as it is, only it is rotated by 90 degrees. So the vector takes the value 0, 1. So you can see the values of x has been given to y and value of y has been given to x. So here it becomes the vector 0, 1. So 1, 0 has been transformed to 0, 1, right? So if I am moving this vector, that is another vector, the same vector which was lying on x, y, that is, now the value was here 1, 0, I'm sorry, 0, 1. If I am rotating this, so this here we saw it was 1, 0. If I am rotating it 90 degrees, it took the value, that is 1, 0 took the value 0, 1. And if I am rotating that 0, 1, it is taking the value, what will be the coordinates here? The coordinates will be minus 1, 0. So what are the values taken by, if I am transforming this, it is taking what? It is taking minus 1, 0. And if I am transforming this to, that is by, I am rotating it to 90 degrees, so the values will be what? What will be the values? 0 and minus 1. So if I am transforming this vector, that is rotating this vector by 90 degrees, it is taking the value 0, minus 1. And if I am rotating this by 90 degrees, what will be the value taken? The value will be, and that is, you can see 1, 0 back, 1 and 0. So here if you look at all the four, x is given the value of y and y transformed to x. But here you see it is just not transforming x to y, it is x is being transformed as minus y. So here if this is y, you can see y remains as it is because it is 0. And now it is y, it is taking 1. So it has to be minus 1. So minus 1 of minus 1 becomes positive 1. So what is the transformation? xy is minus y and x. So you can see here, I can represent this in terms of the angle theta. So I can have, assume that if I am having a transformation, that is, I can represent the transformation matrix. That is, it converts to x and yx. That was 1, 0 is converted to, you can see the value of this x1. Sorry, the value of x has been taken here and value of y has been assigned to x. And here it was, the original matrix was 0, 1. You can see the x has been assigned to y and y has been assigned to minus x. So that is the transformation from the identity. So now here you can write that in itself as this, as when you are rotating it, by assume that you had a transformation. Before transformation it was lying on x-axis. So after transformation now it is lying on y-axis. So I can call it as cos 90. Cos 90 becomes what? Cos 90 is 0. I can represent this as cos 90. And this as sin 90. Sin 90 you can see it becomes what? Sin 90 is 1. So I can represent instead of 0, 1, I can represent in terms of the angles cos theta and sin theta. Another this one column you can see, it can be represented as minus theta, that is minus sin 90 and cos 90. So you can have the same transformation, that is 0, 1 being transformed to, if I am rotating it like, if I am 0, 1, if I have the original matrix 0, 1 and 0 when lies on y axis, if I am rotating it by 90 degrees, it lies on the minus x axis. So it is something like, again rotating it, that is total 1, 0 has been rotated to, that is sine 90, that is cos 90 plus 90 or sine 90 plus 90. It's something like minus sine theta and cos theta you will be getting. Or you can just write it as cos theta and another minus sine theta minus sine theta. Or you can say xy being transformed to minus y and x. So instead of writing whole cos theta, sin theta, you can write here c minus s, s and c. S represents sin theta, c represents cos theta. So this is how you are developing a rotation matrix. This was just an example for developing a rotation matrix for 90 degrees rotation anti-clockwise. So you can have the same matrix can be developed for in the backward, that is for the clockwise direction. So we'll call it as minus q, and for minus q what happens you can see here. So we are going in the reverse direction. 1, 0 is being transformed to 0, 1 and 0 being transformed to minus 1, 0. You can see x and y values have been interchanged, but the x value is taking what? X value is being assigned to minus y. So that is x being here, y is equals to, you can say y is equals to minus x, right? And whereas x here is equals to your y. So y minus x, the transformation xy transforms to y minus x. You can just check it for the vectors. This now if it is xy, this was xy, what happens to this? And when this is xy, I'm rotating it by 90 degrees. What is the values? And if I'm rotating this by 90 degrees, you can check for all the 4 rotations, and then this holds good. That is xy is transformed to y and minus x. So similarly, I told you you can rotate it, you can represent it as cos theta and minus sin theta, and cos theta. You are rotating it by minus 90 degrees. So cos minus 90 and sin minus 90. So you can have cos 90 is 0 minus sin 90, that is minus 1. You can represent the rotation matrix backward, or that is clockwise. You can have c minus s and s c. And one more interesting point to note is that if you multiply the rotation angles, one is anti-clockwise direction, another clockwise direction, you get an identity matrix. That can be checked here. You have a rotation matrix here and one more matrix here. Theta and minus theta, if you multiply, you will be getting 1 and 0. That is c into c square, and you know the identity matrix, that is cos square plus sin square theta is how much? That is equals to 1, right? So you will be getting this 1, and the other value you will be getting it as 0, because cs minus cs, that becomes to 0. Okay? So this has to be noted that you can find out the rotation, other and rotations using this identity matrix. So this is about the rotation. And one more thing you can note down is square of that is square of theta, that is rotation matrix, or that is 2 or square of the rotation angle matrix, or the shift itself. Instead of, that is 2 theta, you are shifting the vector by 2 theta. Both are equal. You can see here 2 vectors have been multiplied, and you are getting this, and you know that c square minus s square can be written as cos 2 theta, and this also, that is 2 times of cos theta, and sin theta can be written minus sin theta. And now you see the angle. Before it was, here it was theta, and the angle has been converted to 2 theta. So squaring is nothing but you are rotating it twice. Okay. So this completes about the rotation.